folks, and welcome, and thank you for checking out my video on the water quality database I developed for Little Traverse Lake and the Little Traverse Lake Property Owners Association. By way of introduction, my name is Ray Canale. I'm an emeritus professor from the University of Michigan. I taught in the Department of Civil and Environmental Engineering for over 25 years in various aspects of water quality engineering. This is the main menu for the database. Notice that there's a map of the stations in this database. There are 9 nearshore in blue, 2 tributary in one in red, and 1 green offshore. Then there's a selection of 7 different buttons that take you to various sections of the data, along with a documentation page that you can simply open by clicking and then closing it back down. Notice that this is developed using Excel, and Excel is being used because it's ideal. It's a powerful tool for this application, has great graphics, data sorting, statistics, and other capabilities that we can take advantage of. It's also easy to document and maintain. The files that are produced are very small, so they can be easily distributed by email. There are millions of users, lots of people are familiar with Excel, and it's all over the world, and it's cheap. I bought my copy for $50 on the internet. The other point is that this application has over 15,000 pieces of historical data. It could be easily expanded to 10 times that with no problem whatsoever. So let's take a look at some of the features. First, let's click on this top one, the offshore chemistry, and we can notice that the design of this section is similar to the other ones. The design is pretty common for all 3 sheets, or all the sheets. First of all, there's a white area down here where new data are entered. Up at the top, there's some selections, and you can pick a year and a parameter for 2 different graphs. And when you do that and you click this update button, it searches all the data and finds a match for the parameters you've selected, extracted these data, puts it over in the gray area, and the gray area is what drives the charts. And the scale and the labeling and the average and the rest of the information displayed is automatically updated according to the selections you make. So in this case, we show phosphorus for 2005 versus 1998. And you'll notice a fairly similar pattern. It's low in the spring, builds up during this year, and higher in the fall, probably due to summer activities. The bottom waters are higher than the top, probably caused by release of sediments, release of phosphorus from the bottom sediments. And you'll also notice the concentrations are down here around 4 or 5 micrograms per liter, which is a pretty good indication that this is a phosphorus-limited lake for algal growth. We could also look at other parameters for the same two different years. For example, let's take a look at nitrate and plot that for 2005 and take a look at nitrate for 1998. And we see similar patterns, around 300 or so in the spring, dropping down to quite low values by the end of the summer. And this is an indication that there'll be periods here where the lake is nitrogen limited. And this favors the growth of blue-green algae, which may be certainly undesirable. You can also look at another year, for example, 2020, and notice a similar pattern. You can also look at 2 different parameters for the same year. So for example, let's pick 2020, and we'll pick chlorophyll. And you see it's low in the spring and builds up. Now let's pick Secchi depth. We expect it to go down as a function of time, and there it is. As the algae goes up, the water clarity goes down. So this is also designed, by the way, so that anyone can use it independently. Once you get the hang of this, it's very easy to use. You don't need any outside help to do it, and you can add documentation and notes over here. Also, for example, let's say we get some new data. So let's add some chlorophyll data, and we'll go down here to the bottom, and there's the last value in 2020. Let's put in a value here of, I'll make up a date, 6/9/2021, and I'll use a value of 3, and then 8-9-2021, I'll put in a value, let's say 4.5. So these are the new data that I entered for 2021. Notice the charts haven't changed, but if I go up here and change this to 2021, we should see an update in the chlorophyll values. There they are. And the average has changed along with the scale and all the other indicators on the chart. So let's go take a look at some of the other sections. I'll go back to the main menu. I'll skip over trophic status and the creek chemistry in the interest of time. So let's just take a look at the offshore probe data. The probe data are collected with YSI or HydroLab equipment, and it's the same overall design. The white area for new data, the gray area for extracted data. Make your selections up at the top. This shows temperature for 98 and 2020. And notice they're very similar with mixing in the spring and fall, and maybe even a little cooler here in 2020. We could also compare two different parameters for the same year. Let's pick 1998 oxygen and you'll see the dynamics that we kind of expect here. There's overturn in the spring and fall, the same way with the oxygen. And then the surface oxygens are high, the middle's in the middle. And then here's a long period of depleted oxygen that favors the release, the chemistry favors the release of phosphorus from the bottom sediments. So the longer this duration, the more undesirable it is. We could also look then at 2020 1998 oxygen and compare that with recent years. So for example, 2020 oxygen. Interesting to note, the duration of the depleted oxygen period is smaller in 98, or in 2020. So this is an indication of improving water quality conditions. And let's see if that holds up for some of the other parameters as we move through this. Let's go back to the main menu and skip over the pair fighting and go to the trend analysis. Here's a trend analysis for 1990 all the way to 2020, a 30-year period. It shows Secchi depth getting greater over time, chlorophyll going down over time. So we've looked at the phosphorus dynamics during the year, the nitrogen, oxygen, temperature dynamics, and we're getting a pretty good picture of what's going on here. And notice we've only been at this for about 5 minutes, and you've also already gained some insight that would be very difficult to do if you had to search through the data, plot it on your own, change the scales. I mean, by the time you're finished with that, you kind of lose your train of thought and your ability to look at these data creatively. You also see the max, min, and average and the scatter in the data. So all this stuff builds up into getting a pretty good picture that would be difficult to obtain using any other kind of tool that I can think of. So we go back to the main menu. Let's look quickly at the paraphyton. Paraphyton, here are our 9 sites. Here's our white area where you entered data. In this case, we're going to plot all 9 sites with a bar graph and look at them as a function of time. So here it is on July 11th, 2019. And by just clicking these little buttons for the various sampling dates in 2019, we can see the growth in terms of both spatial and time variation. So that's kind of neat. Heading back to the main menu, the fundamental design and the code and the computer code, are in place for this application. And so that means this thing could be easily expanded into many, many lakes, many, many tributaries, and other parameters as well. All that could be done using this basic design. So in conclusion, I want to thank you for checking in with us. If you would like a copy of the database, I can send you a copy by email, or you can email me with questions and comments. And I've always welcomed these. And you guys have a great day, and thanks for tuning in. Take care. Bye.